Now this is another illustration for Kirchoff law. Now this time we have double loop circuit. So circuit contains, this is one loop, this is another loop. So this is a double loop circuit. We have to find current through 2, 4 and 6 ohm resistor. So we have 2 ohm resistor. Here we have 4 ohm and here we have 6 ohm resistor. Now let us see, we have a battery of 14 volt and this battery is 10 volt. So let us say this battery sends a current of I1 because positive terminal of battery sends current. So I can write this current is I1. Now it reaches here. There is no divergence of this current, so I1 current will go in this direction. Since battery has to be neutral, so this battery will also gain a current of I1. This means through this wire there is a current that is coming, I1. Now this current reaches here. Now let us see something about this battery. Let us say this battery, positive terminal of this battery sends a current I2. So this current reaches here, I2. Now if I apply junction law, what is happening? This current I2 is reaching here, and from I2, I1 current goes in this direction. So only I2 minus I1 current is basically going in this direction. You can apply junction rule here. So you have to have total current coming in, that is I2, that is total current going out, that is I2 minus I1 plus I1, and that is basically I2. So we have basically applied junction rule. If a current I2 is coming here and current I1 is going in this direction, so this wire will have a current of I2 minus I1, and the same current will reach here, I2 minus I1. Now this current will flow through this wire. It will reach here, I2 minus I1. And when this current reaches here, one current I1 is coming from this direction, and from this direction current I2 minus I1 is coming. So finally I2 minus I1 plus I1, that is I2. So this battery will get a current of I2, and that should be, if this battery sends a current of I2, it has to get a current of I2. So one can basically recheck if you are sending current I2. Finally, if you are doing the circuit correctly, you have to have this battery should get a current of I2. Now the second step is writing equation. So let us write equation. So how many unknown we have? We have two unknowns. So we have to write two equations. One can write one equation in this circuit and another can write another equation in this circuit. So there are two ways. Let us write equation in this circuit first. So if I travel from F to E, E to B and B to C and finally to F, change in voltages should be 0. Now I am going from F to E, so we are crossing this one. So final is positive, initial is negative. So there is a gain in potential, that is change in potential is positive, so 14 volt. Now I am going in the direction of current, so there is a loss in potential, that is I1 times 4, because 4 times I1, that is Ohm's law. Now I am crossing this battery. Again I am going to final potential is positive, initial is negative, and the magnitude is 10 volt. So I have to have this plus is 10 volt. Now this is I am going in the direction of current, so there is a loss, that is 6I2, and finally I am reaching at the point F. So sum of the potential differences is equals to 0. So I have 14 plus 10, that is 24, minus this is basically I will have 4I1 minus 6I2, this is equals to 0. I can write 24 is equals to 4I1 plus 6I2. So we have one equation, 4I1 plus 6I2 is equals to 24, or we can write in a simplified way, 2I1 plus 3I2 is equals to 12. So this is first equation. Second equation we can get from this circuit. So let us travel from C to B and from B to A and B to A to D and then finally up to C. So if I am going in the opposite direction, so current is in this direction, I am going in the opposite direction, so there is basically change, that is increase in potential, and that is 6 times I2. And now if I cover this one, that is the final minus initial, that is negative, so minus 10 volt. Now if I cross this one, once again I am going opposite direction of current, that is 2 times, and the current through this resistor is I2 minus I1. And finally I am reaching to the point C, so sum of the potential differences is 0. So we have 6I2 minus 10 plus 2I2 minus 2I1, this is equals to 0. So we can write this is basically 6 plus 2, 8I2 minus 2I1, and this is equals to 10. So we have, this is the second equation. Now we have to solve these two equations, equation 1 and equation 2. So let us say first equation is 2I1 plus 3I2 is equals to 12. 2I1 plus 3I2, and this is equals to 12. Now the second equation we have, that is 8I2 minus 2I1 is equals to 10. So we can basically add these two equations. So if I add 2I1, 2I we cancel, so we will have 11I2, that is 22. So now from here we can say I2 is equals to 2 ampere. And once I know I2, we can calculate I1 from the first equation. 2I1 plus 3 times 2 is equals to 12. So 2I1 is basically equals to 12 minus 6 is 6. So I1 is basically 3 ampere we will have. So current through resistors are basically 2 ampere and 3 ampere. So we can see I1 is basically 3 and I2 is 2. I1. So through this resistor we will have 3 ampere, and through this resistor we will have 2 ampere, and through this resistor we can calculate, that is I2 minus I1. So from 2 ohm resistor, that is I2 minus I1. I2 minus I1, and I2 is basically 2 ampere and I1 is 3 ampere, so this is minus 1 ampere. Minus sign says basically the direction of current which I have taken is wrong. I have to reverse the direction of current. So in 2 ampere resistor, so I can say in 2 ohm resistor, the direction of current should be reversed as shown in the figure, and magnitude will be 1 ampere. Magnitude of current will be 1 ampere. Will be 1 ampere.